Already factors affecting data collection. So some bits to explore here at the beginning. Page 414. You can take a look here too, so you've got the stuff in front of you rather than just hearing me read it, but here we go. A superfood employee provides samples of Bob Brat sausages to customers between 5 p.m. and 5:30 p.m. for one day. Store employees ask customers who buy Bob Brat sausages the following question. Did you buy Bob Brat sausages because they are delicious, quick to prepare, or both delicious and quick to prepare? Here is a survey, and you've got the results there on your page. So, question. From the store's point of view, did Superfoods promote Bob Brat sausages well? Well, I suppose they promoted them. I don't know if well. Talk amongst yourselves if you want there. They promoted them for half an hour and on one day. So 5 to 5:30 there's going to be generally lots of people in a store. But whether that's well or not is probably another story. The next question, did the survey ask a fair question? Well, not really. Are they delicious, quick to prepare, or both delicious and quick to prepare? What if you hated them? That's the first thing. The second thing, who did they ask the question to? That has to do with population. They asked it to the people who bought Bob Brat sausages. So these are people who probably like them already. So was it representative of the whole population of shoppers? No. Okay. Their claim, over 90% of shoppers love Bob Brat sausages because they taste great and save time. Probably a bit misleading. Now, this maybe if we said 90% of shoppers who love Bob Brat sausages, but even then, the 90%, I'm not quite sure where they got that number from. So, probably a misleading advertisement. And you know what? You're going to see misleading advertisements. Hopefully not to this extent, but you see them all the time. On TV, right? You watch commercials for cars, and you've got some like, it's the Lincoln commercials. Matthew McConaughey talking in his low, gravelly voice about how amazing the car is. Or you've got commercials for various beverages showing a certain lifestyle that 99.9% of people who drink whatever beverage, and pick one, whether it's Sprite, whether it's Coke, whether it's something else, are never going to have that lifestyle. So advertisements are misleading. Some of them much more subtly, some of them really overtly, like the one here. Okay. So we can talk about influencing factors. We can talk about the idea of bias. Okay. Oops. Coming back here. Oh, sorry. Settle down. Sorry about that. Bias, when we're talking about, this is page 415, we've got some definitions. I'm going to just talk about them. You guys can write them down from page 415. Pause if you need to. Does the question show preference for a specific product? So if we're asking a survey question, do you buy brand X of coffee because it is the most delicious? Well, there's so many parts to that question that it's very hard for us to say whether the results we're going to get are good or not. So if I said, who doesn't drink, and let's pick something that nobody drinks, Dunkin' Donuts coffee because it tastes terrible. Well, I'm showing a clear bias against the one product. I'm not going to collect good data. Okay? That's the first one, bias. Use of language. Is the question presented in a way that people understand what's being asked? And so, you can get some horribly convoluted questions that don't really help anything at all. Okay? Nobody really knows what you're asking. Ethics, okay? Does the question refer to inappropriate behavior? Or is it biased against a certain like ethnic group of people or a certain cultural group? Cost. Does the cost of the study outweigh the benefits? So we could find out, in Canada, what everybody's favorite hockey team is by doing a exhaustive survey of every person in the country. We would know very precise information about hockey teams, but would that be useful to the country? Probably not. Cost probably outweighs the benefits. Time and timing. Does the time the data were collected influence the results? Is the timing of the survey appropriate? So if you want to know breakfast restaurant preferences, you need to take the survey at breakfast time. Right? If you go in and you're saying, okay, we're going to check and see what people order for breakfast at Tim Hortons, and we go in there and we observe what people are buying from 4 p.m. till 6 p.m., it's probably not going to tell us a lot about people's breakfast choices. Okay, so timing is off there. Also, just like Bob's Brat sausages, have we actually gone for a long enough time to get useful data? If I'm asking questions for 5 minutes one day, I probably can't say a whole lot of real good conclusions about what the whole country can do. Okay, privacy. Do people have the right to refuse to answer? Are their responses kept confidential? Big stuff with this, right? In terms of data collection there. Facebook has been beat up pretty bad, and other social media as well over this in the last few months. Cultural sensitivity. Might the question offend people from different cultural groups? Here we try to be as careful as we can. There's going to be times people get offended by certain questions, and there we have to look and see, does the cost outweigh the benefits? And also, have we done all we can to avoid making people upset? Okay. So, as for each of the following situations, comment on the influencing factors. So, sales representative stands in front of a display of different kinds of toothpaste. He asks every person buying toothpaste what their favorite brand is and for what reasons. So, bias, well, if this is a sales rep, probably he or she is going to, sorry, it's a he in this case, is going to be making sure that they are wanting to buy his brand of toothpaste. That would be the only real bias. There's not a lot of bias in this case. Standing in front of the toothpaste display is fine because he's asking people about toothpaste. Right? If I'm standing in front of the vegetable section and asking people about toothpaste, maybe not the most appropriate area to do that, right? If I'm standing behind my Buy Colgate sign, I'm biased and I'm showing that to people. But if I'm just a sales rep not wearing like a uniform promoting some brand, probably not a lot of bias here. Okay, free samples of sunscreen are sent to every home in fall and winter. A mail reply card asks people if they would use the product again. So, well, obviously timing is kind of silly because people don't use a whole lot of sunscreen in fall and winter. In addition, asking people if they would use the product again assumes that they did use it. So that's maybe a little bit unclear in terms of what the question's asking. Grocery store employees conducts a phone survey of people living within 10 kilometers of the store. To help determine what meat products to sell, she asks what types of red meat people prefer. Well, what about other kinds of meat? What about chicken? What about pork? What about other kinds of white meat? Or other non-red meat? Okay, so a little bit of bias there in terms of assuming that people who eat meat eat red meat. Okay, sales rep conducts a phone survey. As she poses the question, a person receiving the call says, "I'm not interested, thank you." Sales rep responds, "Why not? Your input provides useful information." She begins to repeat the survey question. At this point, they're not respecting the individual's right to refuse. And any responses obtained are probably not going to be terribly valid because the person's just trying to get rid of you. Okay? School is under construction and is quite dusty and dirty. A survey is conducted about the environmental health of your school. The survey is done every 4 years. Timing is off. Obviously, it's going to be dusty and dirty, and the environmental health isn't going to be ideal because you're conducting the survey in the midst of a once in a who knows how long construction. Now, if the school's always under construction, then it's valid, but otherwise, probably not. Okay? People are going to express frustration over temporary changes, even though they're not representing the reality. All right, sales rep sets up an online survey. The survey offers a free MP3 of a file that was downloaded from the internet to everyone who completes the survey. Company has not bought rights to the song. Obviously, ethics are a problem here. Offering a reward to participants in this survey is wrong, generally. And secondly, it's wrong specifically in this case because they're stealing the song. Okay. So, example 2. Write survey questions free of influencing factors. When you ask a survey question, you want the question to be a fair question. The proposed mill will produce 250 jobs and economic benefits for your community. Are you in favor of having a forward-thinking steel mill in your community? Well, this word here, will produce, we could change that to may produce, might produce, and suddenly the question sounds a whole lot different. So there's a problem there. Are you in favor of having a forward-thinking steel mill in your community? Well, we could take this descriptor, this adjective bit out, and we have a much more fair question. We could go with may produce. We could leave it as will produce 250 jobs. And if it's going to produce economic benefits, we should kind of be clear as to what they are. Okay. Right now, we're pushing for a yes with this question. So does the survey question influence results? Definitely. Rewrite the question. I think it would be better to get rid of this whole first thing. Get rid of the adjective. Are you in favor of having a steel mill in your community? Now we've gotten rid of the influencing factors. We're going to find out the actual answer to the question without trying to tip people towards yes. Okay, show you no. Explain whether the question has influencing factors. If so, rewrite it. Daniel's studying the population of polar bears in eastern Hudson Bay. He drafts the following question. You're going to pause the video right now and you're going to actually try this. Pause it. Try it. Okay. See what you think here. Okay, we're going again. Do you think the senseless slaughter of polar bears should be stopped? Well, senseless slaughter, it's got some nice alliteration there. But I think in this case we're, of course we shouldn't senselessly slaughter the polar bears. So depending on what the population of polar bears is doing, do you think that we could influence it the other way? Do you think that problem bears in the eastern Hudson Bay should be killed? Okay. Little bit more fair with my second question, but probably still not great. Influencing factors, though, senseless slaughter, definitely. Okay. And then there's lots of ways you can rewrite it so that it's not influencing factors or causing people to vote one way or the other. Recent study shows that 45% of Canadians are using the internet to shop. I would suggest this is an old number and it's probably higher. Amy develops the following question for a class survey. What kind of products and services do you buy online? Influencing factors. There's not a lot of bad ones here. This is a pretty fair question. We are assuming that people buy online, but in this case, it's if we're assuming 45% of people do, and by today I think we could say that's a higher number. Not a bad question. Perhaps a better question, if we're only 45% and she's checking to see if her class is the same, would be, do you buy products and services online? Okay. Okay, so survey questions should be worded so they are free of any influencing factors. Influencing factors include, and you can get these from above, I'm not going to take the time to write them all down. They include things like, here we are, bias, use of language, ethics, cost, time and timing, privacy, cultural sensitivity. Couple questions. These ones here, I want you to discuss with each other. Okay, that's all I'm asking for that for to happen here. This takes us on to the next section on collecting data. Okay, so some keywords here. Population, these are given on 423. Population is all of the individuals in the group being studied. Okay, so if we're taking a survey of Canadians, it's all people in Canada. If it's Canadian citizen, it's all Canadian citizens. If it's people who live in rural Alberta, it's all rural Albertans. We have to make sure we define what rural would mean. Do people living in the hamlet of Hayes count as rural? Is it people who don't live in cities? Right? We'd have to define that, but the population is all the whole group being studied, and then a sample is a group of individuals selected from the population. Okay, several types of samples. We can have convenience samples. A convenience sample is simply a sample created by choosing individuals from the population who are easy to access. So you're doing a survey of what people buy at the diner, and you go there for an hour and ask people questions as they walk in and out of the diner. Okay, that's a convenience sample. Random sample is a sample created by choosing a specific number of individuals randomly from the whole population. Random means that each individual has a chance of being chosen. As a result, a random sample is likely to represent the whole population. Data from a random sample can be used to make predictions about the population. And then we have two kinds of random samples. We can have a stratified response sample. Okay. This is a sample created by dividing the whole population into distinct groups, then choosing the same fraction of members from each group. Okay, so this might be if we're talking about a sample of all Albertans, and we've got some question based on whether, where you live or something like that. We could do a stratified sample based on size of the town you live in. So it could be people who don't live in a town, people who live in like a hamlet, people who live in a village, people who live in a town, people who live in a city, and then we take 25% or 2% of people from each of those groups. That's a stratified sample. Okay, we could also do a systematic sample, and this is a sample created by choosing individuals at fixed intervals from an ordered list of the whole population. Finally, a voluntary response sample. This would be where you get a survey and fill it out if you feel like it. Okay. Identify the population. Okay. So we have to talk about whether we survey the whole population or just a sample of the population. Okay, so a bicycle store owner wants to know what brand of mountain bike her customers prefer. Population, customers. Probably a sample, although she could do a fairly easy population sample, or at least a convenience sample. She could look at what bikes she sells. Okay, school board wants to know how many hours of homework students do each day. Population is the students. Probably a random sample of some sort. Candle manufacturer wants to know how many of its candles are made with flaws. The population is all of the candles. Here you're going to do a random sample. Or, you're going to sample the population. You're not going to probably look at each one of millions of candles that you make. Okay, for each situation here, describe how a sample could be selected, identify the type. Okay, so teacher wishes to get feedback from her class about the school dance. She plans to survey 5 students out of a class of 30. Probably a random systematic sample would be good here. Telephone company wants to determine whether a fitness center would be well used by its 3,000 employees. Company plans to survey 3,000 employees. Here, probably a stratified random sample. Okay, so we look at people in all the different groups of the company. So whether we have office workers, whether we have people who are out working on telephone installs, whether it's people who are working in tech department, right? We want to look at each of those groups to see and get a certain amount of each of those. Chain store is trying to decide whether to open a store in Camrose, Alberta. Okay, it looks at the population of nearby towns. Okay, stratified sample here. We want to take maybe 25% or 2% or 10% of each of these towns and survey them. Right? Because in Camrose, that's where the store is. That's the biggest deal. If you can have people from that town that's going to use the store, great. If not many people from Bashaw want to go there, well, that's probably okay. But as long as you've got lots of Camrose people. Okay. D, a marketing research company mails surveys to all of the adult residents in a town. Survey asks about brands of consumer products. Asked to mail the responses in a prepaid envelope. This is a voluntary response sample. Okay. The last one here we've got and who is the population? All of the adult residents. Here the population are all these people living in those towns. Restaurant owner wants to know the favorite pizza topping of his customers. He plans to survey every customer who orders a pizza between 5 and 10 p.m. one evening. This is a convenience sample. Population is all of his customers. Okay. Talk through these again as a group. Which takes us on finally to our last one. Alright, this takes us on to 11.3, probability in society. So we can use probability, you can use what societal statistics to make predictions about populations. Okay, so we've got Ruth wanting to determine the most common eye color of students. She surveys all the grade 12 students of 5 of 7 high schools in the city. And here's her results. Lots of brown, decent amount of blue, fewer green, 46 that are other. Okay, from the results, predict how many of the 7,200 students at the local college will have brown eyes. Okay, so she surveyed 2,300. So here we're going to basically say, okay, well, we have 1,656 out of 2,300. This is looking like a ratio, and it is going to equal x over 7,200. That's probably one of the worst x's I've written, at least today. All right. And so we can do a few things, but basically we're going to multiply both sides by 7,200. Okay. You heard me say it. $1,656 divided by 2,300 equals that times 7,200 equals, so x equals 5,184. So roughly 5,184 students at the local college should have brown eyes, assuming that the population is all the same. Is it reasonable? Well, maybe. What if these high schools are, the 5 of the 7 high schools are all private schools with people who are not representative of the population? Then maybe this wouldn't work. Okay. So here we got to talk about what is a biased sample. And a biased sample means that it leans one direction or the other. Okay. So if you take a peek inside your textbook, you can look for a textbook definition here. And we're going to look on page 431. A biased sample does not represent the population. Okay. In order for this to not be a biased sample, the population needs to be the same in the high schools as the college. So this, we have to say that this high school population, where we got the samples from, is the same as the college sample. Okay. Example 2, avoid making a false prediction. Mr. Krutz gave an assignment worth 30 marks. After marking the first 5 papers, he was concerned that the students did not understand the assignment. He predicted most students would not do well. Okay, so you can see his marks there: 20 out of 30, 15 out of 30, 18 out of 30, 19 out of 30, 18 out of 30. Average here, would be about 18 out of 30 probably. So again, we can talk about mean, median, and mode. Right, mean would be, we'd add them all up and then divide by however many. So 20 plus 15 plus 18 plus 19 plus 18. Right, add up the totals. 20 plus 15 plus 18 plus 19 plus 18. Divide by 5 is 18 out of 30. So as a percentage, that would be 60%. Okay, median would be the middle number if we arrange them in order from smallest to lowest, which would also in this case be 18 out of 30. And the mode would be the one that occurs most often, which happens to be 18 out of 30 as well, or 60%. Alright, then we have the scores for all 30 students in the class. Okay, so his first 5, oops, there they are. His second 5, oh, suddenly we've got somebody getting 30 out of 30. Oh, maybe some of the kids actually did understand it. The third 5, everybody's up in the 20s. Fourth 5, well, 25, well, 15, not so good. 28, that's pretty good. This 5, really quite good. There's a 19, not great. So why does Mr. Krutz's sample lead him to make a false prediction? He's only looking at the first 5 kids. Okay. So his mean, median, and mode, you can calculate these here. I'm not going to go through that, but to do a median, again, you have to arrange them from smallest to lowest. No, that would be smallest to smallest. Let's try smallest to biggest, and then you look for the middle numbers. Okay, so the very middle number would be the mode. Okay, that's mode. Let's try that again. That is the median, as I was trying to say. Median is the middle number. Mode would be the number that happens the most often, and mean would be where we add them all up and divide by the total. So we'd add up 20 plus 15 plus 18 plus 19 plus 18 and so on all the way through. There's 30 numbers here. Divide by 30 students in the class to find out the average, the mean. We often use average and mean kind of interchangeably. Okay. Example 3, make a decision based on probability. A youth association surveys its 400 members about their preferred activity. There are 100 members in each of the 4 groups. The activities were chosen from a youth activities resource. The table displays the survey results. Okay, so red group, blue group, green group, yellow group. What's the probability that a member of any group will choose swimming? So here you have to add up all the swimmings and divide by 400. Okay? Because we've got totals. 100 plus 100 plus 100 plus 100 is the total. So based on this, we can predict how many of the 400 will choose swimming. Well, what do we got here? 14 plus 11 is 25, plus 27 is 52, plus 13 is 65 out of 400. So based on this, we should see 65 out of 400 choose swimming. Okay. What assumption did we make? Well, we assumed that these are the only options they have. Okay. Now, we could also, instead of doing the right way like I did here, we could do the wrong way. We could say, okay, well, we got 14%, we have 11%, we have 27%, we have 13%. So we could add those up. 14 plus 11 plus 27 plus 13, and divide that by 100, so 16.25% chance that people will choose to go swimming. Okay. Multiply that by 400 again, and we're back to the 65. Okay, so based on the survey results, predict the probability that a member will choose swimming. It really depends on the group, right? Green obviously seems to like swimming a whole lot more than the other groups. Okay. All right. We can also look at something like theoretical probability. They've got 4 choices, 1 out of 4. That's, in theory, that's what they would choose. Obviously, it's weighted towards watching movies. That's what they like doing the most. All right, some questions for you to work on. I would like you to actually do these ones in your notebook. I don't want you to take homework because you do have this, PAT for science tomorrow, but work on them in class today. Thanks. Have a good day.